So let's solve this problem. So for this basic integration, and take note that for the integral of u to the power n du, this is equal to u to the power n plus 1 over n plus 1. So this exponent must be equal to this denominator, then plus c. And for the integral of dx, so this is equal to x. So if we have this given, the integral of x to the power 3 dx, so using this formula plus 1 for the exponent, so this becomes x to the power 4, so plus 1 for the exponent, then over this denominator must be equal to this exponent. So this is over 4, then plus c. Then if we have this given, the integral of 5x to the power 2 dx. So first, we need to put this constant outside. So this becomes 5, then the integral of x to the power 2 dx. Then apply now this formula. So plus 1 for the exponent. So this becomes 5. So just bring down this constant, then times. So plus 1 for the exponent. So this is 3, then also over 3. Then don't forget to put plus c. And to simplify, so this becomes 5x to the power 3 over 3, then plus c. Then if we have this given, the integral of 7x to the power negative 3, then the dx. So again, we need to put this constant outside. So this becomes 7, then the integral of x to the power negative 3 dx. Then to evaluate now the integral, so just bring down the constant, then times, so plus 1 for the exponent. So this becomes x to the power negative 2, because negative 3 plus 1, that's negative 2, then over. So this denominator must be equal to this exponent, then plus c. And to simplify, so this becomes negative 7x to the power negative 2 over 2 plus c. Then if we have this given, the integral of 4, then over x to the power 5 dx. So first, we need to rewrite this given. So bring up this denominator. So this becomes the integral of 4, then x. The exponent becomes negative, then the dx. Then put this constant outside. So we have the integral of x to the power negative 5 dx. Then apply now the formula. So bring down the constant and plus 1 for the exponent. So negative 5 plus 1, this is negative 4, then over. Also negative 4, then plus c. Then to simplify, so take note, we can cancel. Then we have this negative. So this is equal to negative x to the power negative 4 plus c. Then to make this exponent positive, so just bring down. So this becomes negative. So 1 over x to the power 4, then plus c. Then for this given, so to evaluate now the integral, so we need to integrate every terms and put all the constant outside. So for this term, put this constant outside. So we have the integral of x to the power 3. then the dx, then minus for this term, put this constant outside, then we have the integral of x to the power 2, then the dx, then plus for this term, so the integral of x, then the dx, then minus for this term, so put this constant outside, times the integral of dx, then apply now the formula, so plus 1 for the exponent, so for this term, so bring down the constant, then times plus 1 for the exponent, so this becomes x to the power 4 over 4. So the denominator must be equal to this exponent, then minus for this term, bring down the constant, then plus 1 for the exponent. So this is x to the power 3 over 3, then plus, so this is 1, then plus 1, so we have x to the power 2 over 2, then minus, bring down the constant, 7, and again, the integral of dx, that is x, then plus c. Then to simplify, so this becomes 3x to the power 4 over 4 minus, so we have 4 x to the power 3 over 3, then plus x to the power 2 over 2, then minus 7x plus c. Then for this given, so again, we need to integrate every terms. So for this term, put this constant outside, then the integral of x to the power 3 times the dx, then plus for this term, put this constant outside, then we have the integral of x to the power negative 3 dx, then minus for this term, so put this constant outside, then the integral, bring up this x to the power 2, so this becomes x to the power negative 2, then the dx, then plus, so we have the integral of x to the power 3 over 4, then the dx. Then to evaluate now the integral, so using the formula, plus 1 for the exponent, so we have 5, then times plus 1 for the exponent, so this becomes x to the power 4 over 4, then plus for this term, bring down the constant, then times plus 1 for the exponent, so negative 3 plus 1, this is x to the power negative 2, then over negative 2, then minus, so for this term, bring down the constant, then times plus 1 for the exponent, so this is x to the power negative 1 over negative 1, then plus, so plus 1 for the exponent, so if we have 3 over 4 plus 1, so using the butterfly method, so over 1, multiply, that's 3, then plus 4 times 1 is 4, then over, so this is 4, so that's 7 over 4, so this is x to the power 7 over 4 over 7 over 4, then plus c. Then to simplify, so this becomes 5x to the power 4 over 4, Then this positive 2 and negative 2, so cancel since this one is negative. So therefore, this becomes minus, then x to the power negative 2. Then this negative 4 and negative 1. So negative divided by negative, this is positive. Then 4x to the power negative 1. Then plus. So for this term, we need to find the reciprocal for this 7 over 4. And the reciprocal is 4 over 7. Then x to the power 7 over 4. Then to make these exponents positive, so bring down. So this becomes 5x to the power 4 over 4. Then minus, so bring down. This becomes 1, then over positive 2, then plus 4, then over, bring down. So that's x to the power positive 1 or just x, then plus. So this is 4, then x to the power 7 over 4 over 7, then plus c. Then for this given, so on this case, we're going to use the u substitution, and u is equal to the equation with exponent. So u is 3x squared plus 2x minus 5. Then du, or the derivative of u, so the derivative of 3x squared, this is 6x, then plus the derivative of 2x, that's 2, and the derivative of a constant, this one is 0. So du is 6x plus 2. Then we need to add the dx. Then apply now the u substitution. So we have the integral. So this 3x squared plus 2x minus 5 is equal to u. So this becomes u to the power 4. And this 6x plus 2 dx, that's equal to du. So we have u to the power 4 du. Then using now the formula, so plus 1 for the exponent, so that becomes u to the power 5 over 5, then plus c. Then replace now u with the original value. So u is equal to 3x to the power 2 plus 2x minus 5 quantity to the power 5 all over 5 plus c. Then for this given, so again using the u substitution, so u equals 4x plus 7 and du, so the derivative of u, the derivative of 4x, this one is 4, and the derivative of a constant, that's 0. So du is 4, then we need to add dx. Since in the given, we only have dx, so to solve for dx, divide both sides by 4. So we have du over 4 equals dx. Then apply now the u substitution. So we have now the integral 4x plus 7, that's u. So this becomes u to the power 7, and dx is du over 4. So du over 4. Then put this denominator 4 outside. So this becomes 1 over 4, then the integral of u to the power 7 du. Apply now the formula, so plus 1 for the exponent, bring down the constant, and this becomes u plus 1, that's 8, then over 8, then plus c. Then to simplify and replace this u by the original value, that's 4x plus 7. So we have now 4x plus 7 to the power 8, then over 4 times 8, this one is 32, then plus c. Then for this given, so first, we need to put this constant outside, so we have 5 in the integral of x times the quantity of 3x squared minus 6 to the power 5 dx. Then apply now the u substitution, so u is the equation with exponent, so that's 3x squared minus 6. Then du, so the derivative of 3x squared, this is 6x, and the derivative of a constant is 0. So this is 6x, then we need to add dx. Then since in the given, so this is x dx. So to solve for x dx, divide both sides by 6. So we have du over 6 equals x dx. Then using now the u substitution, so we have this 5, then the integral, so this 3x squared minus 6 is equal to u, so this is u to the power 5, and x dx is equal to du over 6. Then put now this denominator 6 outside, so this becomes 5 over 6, then the integral of u to the power 5 times the du. So apply now the formula, so plus 1 for the exponent, so we have 5 over 6 times, this is u to the power 6 over 6, then plus c. Then replace now the value of u, and u is equal to 3x squared minus 6. So multiply, this is 5 times u is 3x squared minus 6 to the power 6, then all over 6 times 6, this is 36, then plus c. Then for this given, so first, we need to put this constant outside, then we have the integral, and rewrite this radical in exponential form. So this is equal to the quantity of 2x squared plus 5 to the power 2, then over this root, so over 3, then x dx. Then we can apply now the u substitution, and u is 2x squared plus 5, then du, so the derivative of 2x squared, this is 4x. The derivative of a constant is 0, so we have 4x dx. And to solve for x dx, so divide both sides by 4. So du over 4 is equal to x dx. Then using now the u substitution, so just bring down the constant in the integral. So this 2x squared plus 5 is equal to u to the power 2 over 3, and x dx, that's equal to du over 4. Then put this denominator 4 outside. So this becomes 3 over 4. Then the integral of u to the power 2 over 3 du. Then using now the formula, so bring down the constant, then times u to the power 2 over 3 plus 1. So for 2 over 3 plus 1, so using the butterfly method, so this is 2 plus 3 then over 3 times 1, 3. So this is equal to 5 over 3. So to the power 5 over 3, and also the denominator, this is 5 over 3 then plus c. Then to simplify, so we have 3 over 4 then times, so the reciprocal of this 5 over 3, this is 3 over 5, then times u, and u is 2x squared plus 5, so times 2x squared plus 5 to the power 5 over 3 then plus c. Then to simplify, so multiply, this is equal to 9, then multiply over 20, then we have 2x squared plus 5 to the power 5 over 3 then plus c. Or this is equal to 9 times the quantity of 2x squared plus 5 to the power 5 over 3, then all over 20 plus c.